Good morning, students. In this video, we are going to discuss the competency-focused practice questions for ISC class 12th. I'm sure students who are preparing for ISC class 12 board exam have already come across this sheet and in fact must have started solving the sheet. When you go through the questions, you will realize that in many chapters, the level of questions is slightly more difficult than the basic board level questions. Few questions are slightly tricky, they have a different approach. And hence what I've decided is that we'll be going through all these questions chapter-wise. So students, before we start, I want you all to make a note of one thing. All the questions can be easily solved provided you recall all the basic formulas of the normal board level questions. If you are thorough with the board level questions, then you'll definitely be able to solve these questions more easily. So before you take any chapter, before you start with any video, I want you to revise that chapter thoroughly, revise all the formulas from the textbook, whichever textbook you are following, and then you jump into these questions. Directly taking questions of any particular chapter from this sheet may be a bit demotivating because the level of questions is pretty good. After the sheet was circulated a few months ago and when students started solving this, many 12th standard students are worried that why is this experiment done this year? Well, students, that is not in our control. What we have in our control is you still have 3 to 4 months to prepare. In these 3 months or 4 months, if you revise these chapters thoroughly, if you practice these level of questions thoroughly, then you still ace your board exam. So don't worry about things which are not in your control. Use your time wisely and first get the basics clear, and once the basics are clear, then you take these questions. These questions are not that difficult. So without wasting any more time, let us begin with the chapter that we have for this session. So students, in this session, we will be taking questions from the first chapter, that is relations and functions. So let us begin. Now, before we start, students, there are 2-3 concepts which you need to know. I hope you already know them. If you don't, we need to discuss them because these concepts will help you tackle these MCQs. So the first one that you should know is inverse of every logarithmic function is exponential function. And inverse of every exponential function is logarithmic function. For example, we'll understand this with one example. So let's say if we have a raised to x as the function, f of x is equal to a raised to x. This is an exponential function. We will be finding the inverse of this function. Now, how do we find inverse? What are the basic steps? So we always equate the function with y. So y is a raised to x. In this case, because we have x in the power, we will be taking log on both sides. So I'll take log on both sides. So we have log y equal to log of a raised to x. Now, because the base of this exponent is a, I'll take log to the base a. So we get log of y to the base a is equal to x log of a to the base a. I hope people recall this rule of logarithms. This x will come down and it will be multiplied. So from here we get x is equal to log of y to the base a. So students, you have to recall this rule. I hope you already knew this. If not, I hope this makes sense. And this is what you need to remember. Inverse of log is exponential and inverse of exponential is log. Now, other than this, what you need to know is for 1 function. Now, you know the basic procedure. We start with f of x1 equal to f of x2. We prove that x1 is equal to x2 and then it is 1. For 1 function, there's one more method which you need to know. And that is actually an application of derivative to check whether a function is 1 or not 1. Let's consider a function whose graph is something like this. Do you observe from the graph, students, this function is clearly 1. For every value of y, there is one value of x and vice versa. Now, if you also look at the nature of this graph, this function is actually an increasing function. Now, I'm linking this with application of derivatives. I hope you remember increasing function basically means that derivative is greater than 0. So if there is a function and we have to check whether it's 1 or not, if we can prove that the derivative is greater than 0, that is, it is increasing function, then we can say it is 1 function. Other than this, I hope you also understand if it's a decreasing function, it is still 1 function. So the derivative either greater than 0 or less than 0 for all values of x, then it is 1 function. Other than this, students, the next thing that you need to know is how to test 1 function and how to test whether the given relation is a function from graph. So here I introduce you to 2 tests. We call them the horizontal line test and the vertical line test. The horizontal line test is basically to test whether the function is 1 or not. So let's consider a graph something like this. Now, what is the definition of 1, students? The definition of 1 is for every value of x, there should be 1 value of y, and vice versa. For every value of y, there should be 1 value of x. So here, students, The horizontal line test basically means we'll be making horizontal lines. When I say horizontal lines, lines which are parallel to x-axis. So let's consider this line which is parallel to x-axis. Do you observe that this line cuts the graph at 2 points? And therefore, this function is not 1, 1. It basically means, students, that at this x coordinate, let's take an example, -3 and -half, the corresponding y coordinate is same. Let's say the y coordinate is 2, which means that f of -half is also 2, f of -3 is also 2. And therefore, it is not 1, 1. So when will it be 1, 1? If we have a graph in which, when we make horizontal line from any point, you make n number of horizontal lines, they cut the graph at one single point, that is 1, 1. Other than this, to test that it's a function, for that, we have the vertical line test. Now, for that, you need to recall the basic definition of function, students. Do you remember the basic definition of function? The basic definition of function goes as every element from the first set, when I say first set, we are talking about x. Every element from the first set should be mapped to exactly one element of the second set. So let's take an example. This goes on till infinity. This also goes on till infinity. So in this case, students, you have to test that for every value of x, there is exactly one value of y. And for that, we make the vertical line test. So parallel to y-axis this time. You make n number of lines. If it cuts the graph at one single point each time, then we can say it's a function. So in this case, it's a function. Because you make n number of vertical lines, it's going to cut the graph at one single point. So this will be a function. So students, that is how we check 1, 1 and whether it's a function or not using the horizontal and the vertical line test. So now, students, let's get going with the question. The first question that we have is question number 1, where h of x is equal to 4 raised to x, and they've given h inverse x is equal to 2. We have to find the value of x. Now, students, you have to understand we need to find the inverse of this function. So over here, we have just discussed that inverse of exponential function is log and inverse of log is exponential. In this case, when we start with y is equal to 4 raised to x, we'll take log on both sides. So log of y, and the base this time has to be 4, will be log of 4 raised to x to the base 4. So this x comes down, log 4 to the base 4 is 1. So therefore, x is equal to log of y to the base 4, which means my h inverse x is going to be log of y to the base 4. Now, students, when we say h inverse x is 2, we have to simply replace, I'll replace this y with x. So this is the inverse. H inverse x is 2. So this is equal to 2. Log of x to the base 4 is equal to 2. Which means, students, that x is equal to 4 raised to 2. And that gives the answer 16. I hope you know this rule also. You must have come across this rule in integration, where one of the types is integration e raised to x into f of x plus f dash x. There you must have come across this rule that if log x to the base e is t, then we write it as x is e raised to t. This is how we convert a log function into an exponential function. I hope you already knew this rule. So this is the answer. Question number 1 has this answer, option D, 16. Next, in question 28, for any two real numbers a and b, we define a or b if sec square a minus tan square b is equal to 1, then r is transitive. Here, students, sec square a minus tan square b equal to 1. In this, you have to understand that we already have this identity sec square theta minus tan square theta is 1. So do you understand that this rule will be true when the angle a and b are same? And therefore, in this first statement, we can say a is equal to b. When we say a is equal to b, do you understand we are talking about all the ordered pairs a comma a, which means our relation R, if let's say we take some examples, will be 1, 1, 2, 2, 3, 3, and so on. And there's no other ordered pair which will be there. So all the ordered pairs will have both elements equal. Is that relation transitive, students? I hope you know this rule that a relation is transitive unless we can prove that it is not transitive. In this case, it is transitive. So statement 1 is true. Statement 2, students, they're saying that the relation R on this set defined by R is equal to 2, 2 is not symmetric. Well, that is false, students, because 2, 2 is mirror image of itself, and therefore it is symmetric. So here, statement 1 is true, statement 2 is false. So option C is correct. 1 is true, 2 is false. In the next one, students, f of x is equal to 1 upon x raised to minus 2. When you use indices, this is basically x squared. We have to check whether it's injective, surjective. They're saying it's neither injective nor surjective. For injective, students will state that x1 square is equal to x2 square. Injective means 1, 1. I hope people know this. When you take square root, we'll get x1 is plus minus x2. We'll get plus minus because it's R to R, and therefore we can say it is not injective. So this is true. The first part is true. About surjective, we'll start with y is equal to x square, which means x is root y. Now, students, root of negative numbers are not real numbers, and therefore we can say that it is not surjective. And therefore, students, this is true. Statement 1 is true. About statement 2, cube root of x raised to 9 is basically x raised to 9 by 3, which is x cube. So the function is x cube. We have to check whether it's 1, 1 on 2 for integers. So students, x1 cube is equal to x2 cube. We are using the basic rule. When we remove the cube root, we'll get x1 is equal to x2, and therefore it is 1, 1. It is definitely 1. About surjective students, we'll get y is equal to x cube. So x is equal to cube root of y. Cube root. Now here students, we're talking about integers. So cube root of, let's say, a 7 will not be an integer. This will not be an integer. And therefore, we can say that this is not surjective. But it was injective, and therefore, this statement 2 is false. So 1 is true, 2 is false. The correct option is option C. Let's proceed to the next question, which is question 36. It's a very basic question. We'll be using the arrow diagram in this case to understand whether the assertion is true or false. So here, students, in the assertion, we have this f from m and pq up to 11, 12, 13, 14. So I'll make one arrow diagram quickly so that we understand this easily. You can do it without the arrow diagram also. So we have m and pq. This is 11, 12, 13, 14. The function is such that m is mapped to 11, n is mapped to 12, p is mapped to 13. You have to check whether it's a bijective function, students. Clearly, this is not onto students, and therefore we can say it is not a bijective function. In fact, this is not a function because q is not mapped to any element. So the assertion is false. About the reason, so we have m, n, p this time, and we have 11, 12, 13, 14 this time, where m is mapped to 11, n is mapped to 12, and p is mapped to 13. Is this 1, 1, students? Well, this is clearly 1, 1. It's not onto, but that is not the reason that they're asking. So reason is true, assertion is false. And that gives us the option D as the correct option. Moving ahead, students, question 41. Students, the assertion is that it's not a 1, 1 function. It's a graph-based question, students. We just discussed in the starting of this video that to check whether it's a 1, 1 function, we'll use the horizontal line test. So we'll make one horizontal line. You can make it anywhere. If you check, this cuts the graph at more than 1 point. And therefore, we can say this is not a 1, 1 function, which means assertion is true. About the reason, they're saying if any straight line parallel to y-axis does not cut the curve at more than 1 point, it represents a function. Do you understand when we say parallel to y-axis, we're talking about the vertical line test. The reason is true because that is the definition of the vertical line test. If it cuts the graph at 1 point, it is a function. And therefore, assertion is true. The reason is also true, but the reason is not the correct explanation for the assertion in this case. So option B will be the correct option. Moving ahead to 51. 51 and 52 are the next in line. In 51, we have this function x squared plus 2x minus 3. We have to check whether inverse exists. When we say inverse exists, we have to prove it's 1, 1 and on 2. And given that the minimum value of x squared plus 2x minus 3 occurs when x is equal to minus 1, we have to explain why will the inverse occur. Now over here, students, for 1, 1, what I'll do is I'll simply take f dash x. The derivative is 2x plus 2. I'm trying to prove that it's an increasing function because if I can achieve that, then we can say that it is a 1, 1 function. They're saying the minimum value occurs when x is minus 1. And over here, students, when we check the derivative, when is it greater than 0, we figure out that this will be true when x is greater than minus 1. Do you understand, students, that when x is greater than minus 1, the derivative is going to be greater than 0. And therefore, we can say for all values greater than minus 1, it is a 1, 1 function because it is increasing function. When they say that the minimum occurs at minus 1, it basically means that at x equal to minus 1, we have the minimum value. And then when you keep on increasing the value of x, the y coordinate will also keep on increasing because it's an increasing function. So 1, 1 is clear because it is increasing, it is 1, 1. For onto students, this is an algebraic function. It's a simple algebraic, in fact, a quadratic function. Do you understand for every value of x, there will be some value of y? And because all the values in the y column will be mapped, we can directly state it's an onto function. Because it's a plain algebraic function, it's directly onto. So it's 1, 1 onto, and therefore it has an inverse. Moving to 52, students, explain why is it not a symmetric relation. For this, you can simply take some example, student. We have x plus 4y equal to 12. Now we are talking about natural numbers in this case, students. Let's take a natural number, x as 4, then y will be 2. You observe 4 and 2 will belong to this relation. It will satisfy this condition. But on the other hand, if I check for 2, 4, then that gives me 2 plus 4 into 4, which is not 12. And therefore, we can say 2, 4 does not belong to the relation R. And therefore, it is not a symmetric relation. Next, students, we are taking question 71 and 72. In question 71, it is given that f and g are the functions, and this is the table given to us. So here we are finding f inverse 8. Now, students, you have to basically understand f inverse 8. Let's assume that the answer is equal to some value x. When I transfer inverse on the other side, it is as good as f of x equal to 8. So you have to just figure out that value of x for which f of x is 8. So x is 3, and then we get f of x is 8, which means f inverse 8 is simply 3. Now, when they say it's a linear function, now here you have to understand that linear function basically means a straight line. Now, we know that equation of every straight line is of the format y equal to mx plus c. So students, for a linear function, what we'll do is we'll take it as y equal to mx plus c. Y is equal to mx plus c. We'll find m and c. M and c are the two unknowns which we need to find. So if I take x as 0, then y is going to be minus 4. And therefore, when you substitute in this, when y is minus 4, m is 0, we get c is directly minus 4. Other than the students, if we take x is equal to 3, then y is equal to 8. So when you substitute y is 8, x is 3, so this is 3m plus c. You substitute c, you get 8 is equal to 3m minus 4. From here, you get m is equal to 12 by 3, which is 4. So the final y equal to mx plus c, the line, equation of line is y equal to 4x minus 4, which means the function is equal to 4x minus 4. So this is the final function. Next, students, we'll move to 72. In question 72, they're saying a function f is called self-inverse function when f inverse x is equal to f of x for all values of x in the domain. Now here f of x is given. We have to show that it's a self-inverse function. We'll do a simple thing, students. We'll find the inverse. I hope you know how to find the inverse. So we'll start with y is equal to pi squared by x. Here y is the subject. We'll make x the subject. When you cross multiply, x is equal to pi squared by y. So students, we get f inverse x is equal to pi squared by y. We'll replace it with x, which is pi squared by x. You observe f inverse is clearly equal to f. That's it. As simple as that. Next, question 100. The next two questions that we have are question 100 and 102. In 100, they are saying if f is a real valued function, f of x is given to us, it is root of 25 minus x squared, and it's an onto function, then find the codomain for f of x. I'm sure people know this, that if it is a onto function, then codomain is equal to range. So over here, we have to basically find the range of this function. Range means the values of y. This is actually based on your grade 11th concept, find range. I hope you recall the procedure. We'll start with y is equal to root of 25 minus x squared. Currently, y is the subject. You have to make x the subject. So when you square both sides, it's y squared equal to 25 minus x squared. So x squared is equal to 25 minus y squared. So x is equal to root of 25 minus y squared. So students, here we get x is root of 25 minus y squared. Once you get this, students, we can now say that 25 minus y squared, because it is inside a square root, it has to be greater than or equal to 0. So now we have 5 plus y into 5 minus y, and that is greater than or equal to 0. You solve this by wavy curve, students. This is minus 5, this is 5. Now, when you use the wavy curve, I hope you already know this. You take a random value, I'll take 0, we'll get positive. So this is the wavy curve. So here, students, the values of y are between minus 5 to 5. So now, students, the range in this case we are getting, because it's a square root function, we'll say that the range is always positive, and therefore it is 0 to 5. So this is the range, which means this is the codomain. In the second one, students, where we have to check for 1 function, this is very simple. You can take some examples and do it. You can go with the theoretical method, f of x1 equal to f of x2. Because it's a square function, you will at the end get x1 is equal to plus minus x2. I'll take a couple of examples over here. So if we take f of 3, students, when you replace x with 3 in this, root of 25 minus 9 is 16, we get 4. When you take f of minus 3, students, we still get 4. And therefore, it is not a 1 function. In the second one, we have to find the values of a for which f of a is 4. F of a here is root of 25 minus a square. You just have to solve this equation. When you solve this by squaring both sides, 25 minus a square is equal to 16. You get a square is equal to 9. A is plus minus 3. So these are the values of a for which f of a is equal to 4. With that, we complete question 100. Let's move to question 102. In 102, students, you have to find derivative of f inverse x. It's simple. You find f inverse x and then you take derivative. As simple as that. For finding inverse, we'll have to prove it's 1, 1 on 2. I leave that part up to you. I'm sure you will manage it. I'm directly showing you the inverse part. We'll start with y is equal to x plus 1 upon x. We have to make x the subject. So we'll first take x square plus 1 upon x. Take LCM. You take it on the other side. X, y is equal to x square plus 1. Take everything on the same side. We have x square minus xy plus 1 equal to 0. This is a quadratic equation, students, in variable x. The coefficients are 1, minus y, and 1. So now, students, we come to x is the formula method, minus b plus minus root of b square minus 4ac upon 2a. So x is equal to minus b over here will be y plus minus root of b square minus 4ac upon 2. So here we get, students, f inverse is either y plus or y minus. We have to now figure out which one is true. And that decision will be based on the domain and range that we have. Now here we have two possibilities over here. X will either be y plus root of y square minus 4 upon 2, or x will be y minus root of y square minus 4 upon 2. So students, we have to choose which one is correct. So here, students, let's take one example. Now the values of y, do you understand, is the range, which is 2 to infinity, where 2 is included. So let's take any random value of y within that interval. I'm taking y is equal to root of 13. I'm taking y as root of 13. When you take y as root of 13, students, x will be root of 13 plus. Now, root 13 square is 13. 13 minus 4 is 9. Root 9 is 3 upon 2. And in this case, it's going to be root 13 minus 3 upon 2. When you solve this for the students, x is equal to root 13 is approximately 3.6 plus 3 upon 2. This comes down to 3.3. When you solve this, students, this is 3.6 minus 3 upon 2, which is 0.6 upon 2, which is 0.3. Do you observe, students, 0.3 is not a part of x, which is domain. And therefore, we can say that in this case, the function is y plus root of y square minus 4 upon 2. So here we figure out the f inverse, students. So we get from here f inverse x is equal to, we'll replace y with x at the end, so it is x plus root of x square minus 4 upon 2. Once you get f inverse in this sum, we have an additional step. We have to find the derivative. I leave that part up to you, students. I hope you already know derivative, students. If you don't, may God save you. Next, question number 121. So this is the last question of relations and functions. A part of the graph of this function, the function is already given. It's a cubic polynomial, is shown below. Explain why f does not have an inverse. Students will first check whether it's 1, 1 or not by the horizontal line test. Do you see by the horizontal line test, this line cuts the graph at more than 1 point, and therefore it is not 1, 1. Further, the domain of f is restricted to a to b. We have to now figure out what are the values of a and b. They're saying a is negative, b is positive, such that f will have an inverse. You have to understand, students, that f will have inverse when it is 1, 1. This whole graph is not 1, 1, but some part of the graph is surely going to be 1, 1. Now the trick, the concept over here is, students, to identify where is it 1, 1, we will have to check the turning points, students. When I say turning points, if you look at this particular point, let me just shade this for you, students. From this point till this particular point, students, this is where it is 1, 1. So here, students, you have to understand, to figure out a and b, we have to actually use maxima minima concept. It is a combination of relations functions and application of derivatives. So I expect people to know how to go about with maxima minima. I'll quickly run through it. You have to first take the derivative. Derivative is 6x square minus 6x minus 12. You take 6 common, you'll get x square minus x minus 2. You do splitting the middle term, you will get x minus 2 and x plus 1. We'll take the double derivative, students. The double derivative over here is going to be 12x minus 6. The values of x, by the way, when you equate this with 0, will be minus 1 and 2. So these are the turning points, minus 1 and 2. So over here, students, do you understand? Either the maximum or the minimum is going to be at 1. We can clearly see in the graph. And they're not asking us the maximum minimum. So I'll stop at this point, because once we have the turning points, our job is done. So over here, students, a is minus 1 because they're saying a is negative, b is 2. So the interval is minus 1, comma 2, both included. We define the domain and range of f inverse, students. Students, you have to understand that over here, the domain of f, let me just write it over here. The domain of f is minus 1 to 2. We just figured it out. Range, students, means the corresponding y coordinate. For that, we'll simply substitute minus 1 and 2 in this original function. We are basically finding the maximum value and the minimum value. So let us replace minus 1 and 2. When you replace 2 in this function, students, I'll do that for quickly. This is 16 minus 12. This is minus 24 plus 8. So it's going to be minus 12, students. Minus 12 is the minimum value. When you substitute minus 1 in this, students, this is going to be minus 2. This is going to be minus 3 plus 12 plus 8. So it's 15, students. So it's minus 12 to 15. This is the range. For f inverse, students, the rule is very simple. Domain of f inverse is actually range of f. So it is minus 12 to 15. The range of f inverse is domain of f, and therefore it is minus 1. So students, with this, we complete this particular question. With this, we complete all the questions for relations and functions. I hope you understood them. You have to practice these questions thoroughly. You have to give it a try on your own and use this video as a reference. Don't just sit and copy. That will not help at all. Thank you.